Okay, in the last video, we started off talking about exactly what the definition was of the parabola, and I stopped by talking about that the distance from the focus to the vertex is some a distance, and that's also the distance from the vertex to the directrix line. And then because of symmetry and the way that parabolas are set up, then the latus rectum, that line that runs through the focus and connects as its endpoints the parabola, is a 4a distance, which means because of symmetry we have 2a on one side and 2a on the other side. Alright, now all of that is great and fine, but what in the world are these a's that would probably be helpful? Well, that's part of the formula for parabolas. Now, I don't know if you can see this really well because sometimes it doesn't show up really nicely. But we have our first formula for a parabola is here, and it says x minus h quantity squared equals plus or minus 4a times y minus k. If our parabola is in this form, where the x value is being squared, then that means that we have a parabola that opens up or down. And if you think about it, that makes sense because these are the ones that you've talked about so far. Remember the ones that look something like maybe y equals 2x squared plus 3, and we knew this was a U-shaped graph, a square graph, that was much skinnier because it was multiplied by 2, and it was raised up 3 units. That was the transformations. And then if we had had something like this, the only difference between these two were this one opened up and this one opens down because of the positive or the negative in front of the x squared. Remember all of that? Okay, so we've actually already dealt with the ones that were x squared. This is just in a slightly different format. Instead of it being y equals, we're going to look at it now as x minus h squared equals. Alright, well the vertex is that h and k point. So instead of it being an x and a y, we're going to give it that very special name of h comma k. And then it also says here, I've written out again that a is the distance from the vertex to the focus, a is the distance from the vertex to the directrix, and 4a is the length of the latus rectum. When it is in this proper standard form, we can read off the vertex, the h and k, and we can also see the exact length of the latus rectum because it is 4 times a. It's right there with us. We can tell whether it opens up or down by the positive or the negative, and we can also tell how far it is from that vertex up to the focus and down to the directrix because that's an a distance. Now, it could be in this form, or the other form that it could take is if y is being squared. So that looks like y minus k equals plus or minus 4a times x minus h. So the only thing different here is that in one of these, the x is being squared, and in the other one, the y's are being squared. The h and the k is still the vertex. The 4a is still the length of the latus rectum. A is still the distance from the vertex to the focus and from the vertex to the directrix. The only difference here is since the y is being squared, this formula tells us that it's going to either open to the left or it's going to open to the right. Now think about that. If it opens to the left, that is, if we were looking at a number line, say here is 0, wouldn't the numbers here to the left be the negative numbers? So if the 4a position is negative, that tells us that it's going to open to the left in the negative direction. If it opens to the right, it's going to be because the 4a position is positive. Because again, if you think about it, to the right in the number line are positive numbers. So the plus or the minus tells you which way it opens, either in the negative or the positive direction. But everything else about this is exactly the same.